Welcome to EDU World Space.
Okay, for this problem we're trying to determine what is the magnitude of the velocity of ball A and ball B once being struck by ball A with some initial velocity VO when ball B and C are at rest. So this is a conservation of momentum problem. So we have initial momentum equals final momentum. But in this problem we're going to end up with two unknowns, VA and VB for the finals. So we need two equations. So we can break this down to components. Initial x equals final x, and initial y equals final y. Right? So now we have two equations, two unknowns, and we can solve what we need. Great. So for the x component, we're going to have the mass for the initial velocity is going to be the mass times that initial velocity, and then it's going to be the x component, so it's going to be cosine of 45 degrees. And that's all there is for the initial. For the final, we're going to have m. We're also assuming they all have the same mass, m. We're going to have m times va, which is the velocity that ball A goes off at after it strikes B. So, and this is going to be sine of 4.3 degrees. And we're going to have then the mass and VB, and this is going to be sine again, since we're looking for that x component, 37.4. And then we're going to have VC, which is going to be cosine, because we're looking again for the x component, so we need the cosine to give us that adjacent. So it's going to be cosine of 30 degrees. Okay, and then similarly for the y, we will end up with an equation that looks like this, m, where the m's are going to cancel. So we're not even going to write them for this one. So it's going to be VO sine of 45. Because all we basically are doing is flipping from if it's cosine or sine, if it's sine or cosine. And you have to pay attention if it's negative or positive. So all the x components are positive because they're all going towards the right. But for b here, it's going to be going down, so we need to make sure to make that negative. So again, we're going to VA cosine 4.3 degrees now, and it's going to be minus VB sine 37.4 degrees, and then plus VC sine of 30 degrees. I'm sorry, and this was supposed to be cosine 37.4 degrees. Okay, so now let's plug in some numbers. We know what VO is, we know what VC is. So if you plug in all these numbers and everything, you should end up with, after doing a little bit of algebra, should end up with 3.038 equals 0.075 VA plus 0.607 VB. And then for the y, we should have 5.340 equals 0.997 VA minus 0.794 VB. Okay, so now we want to solve one of these equations. We can solve it for either for VA or VB. The way I'm going to do it, and there's multiple different ways you can do this, is that I'm going to take the whole of equation A and multiply both sides by 1 over 0.607. So that's multiply the whole of equation x, then add it to the whole of equation y when I also multiply that by 1 over 0.794 y. All right, so multiply by both sides of y and both sides of x and then add those equations together. You can see what this is doing. For instance, for the x component, it's going to cancel this, so all we're going to be left is VB. And then for the y, it's going to cancel this, and we're going to be left with VB again. So when we add these two equations, when we add them, the VBs are going to cancel, and all we're going to be left is VA, and then we can solve for VA. So once we do that, after we've canceled for VB, the equation should look like this: 6.725 equals 1.256 VA, and thus VA equals 8.5. And now, all we need to do is put VA into one of these equations and solve for VB. And then we'll get that ultimately VA equals 8.5 feet per second, and VB equals 3.95 feet per second. And that's all there is to it. Thanks.